Hi, my name is Josh. I am a rising sophomore at Hebrew Academy of Nassau County. For my starter project, I built a Minty Boost portable charger, and for my main intensive project, I built this screw-propelled vehicle. Now, it may look weird, but basically it's just, instead of wheels, I created these screws from a 3D modeling software. First I'll demo it, and then I will tell you how it works. Okay. Sorry, the motor shelf is on right now, but all right. So that was the demo. But the way it works is that you have these screws here, and they're attached to a motor over here, and it uses the different rotations of the motor to move in different directions. So if both motors are moving either counterclockwise or clockwise, the screw-propelled vehicle will move left and right like it did in the demo. But if one of the motors is moving clockwise and the other is counterclockwise, it'll move forward and backwards. And so there are plenty of challenges that I faced building this because this is a student-defined project. So there's no instruction manual that came with this that I could just follow. So everything here you see is just built from scratch, built from my mind. And so I went straight, when I got there, I researched like how I'm going to build the screws, what's the best angle of the thread over here, how to build it. So I went to Onshape, which is a 3D modeling software, and I created these screws, which were 3D printed. And I created these wedges over here, and those were laser cut. And so that was very challenging as well to actually be able to put everything together. I came in here into Bluestamp with really barely any experience in coding, in the coding aspect with like Arduino, which is what actually controls this thing and allows it to move in different directions. And so that was also a very challenging aspect of this project. But overall, by the end of this project, you know, I'm really amazed that I could just come from barely any experience and come out with a fully fledged project and really get the experience and skill that now I can take this on to the future, and because now I know how to start from scratch, start from nothing, and build a really just like on myself individually build a really cool project like this, and I can take that skill on for the rest of my life. But I'd also really like to thank my instructors, Neil, Aleko, Rain, Mohit, because they really helped me get this project running, going. They spent a lot of time with me, and as well as 3D printing the screws, because each individual, well, both of the screws together to 3D print, it took 36 hours. So, you know, I have to thank them to really just like for getting that done for me. And thank you for listening. Any questions?
This is actually very cool, and this is, this is actually a comment. This is really cool, and this kind of been an inspiration for me because I myself is know how to talk. I myself is in a robotics program, and I'm doing scratch and stuff. And when I'm like in high school, I want to go to Blue Secondary.
Why screw proposing? What's the difference between normal, if you have 4 wheels against?
All right, so I was looking through the project book, and I saw the omnidirectional robot, and I said, you know what, that's really cool, but I want to do a spin-off on that, and I want to make my own unique spin-off on that. And so I researched omnidirectional vehicles, and I found screw propulsion. And what screw propulsion is that like I said, it uses the direction of the screws to move in any direction. But if you're looking at it between screws or a regular omnidirectional robot that uses these mechano wheels to move in any direction, an advantage of the screw propulsion is that in an ideal situation, it would actually be able to go through mud, through dirt, through sand, even through water if it's buoyant enough. So that would be an advantage of screw propulsion as opposed to regular omnidirectional robots.